calculations using the right words to do this. Don't give me a flip over. Don't give me a move to the left. I want horizontal shifts, vertical shifts, reflections. Okay, and vertical stretch and vertical shrink by a factor of. So tell me if you have any questions through any of these. This was just a basic graph, and they listed it as this one just so that you, I think we went over this, just so that base 6 is the same as base 2. It just hugs the axis a little tighter. And it has the same attributes no matter what base you use. So I want your sketches to look very similar. This took your basic core graph, your basic log 6, horizontal shift, a horizontal shift to the left too, it goes the opposite way. So you shift it to the left too, and you do a reflection in the x-axis, and any horizontal shift is going to change your domain. Any vertical shift will not. So if your domain moves, move your axis, move your domain. You could start with your domain 0 to infinity and say -2. You could take this and use your algebraic representation. You know it has to be greater than 0. X has to be greater than -2. Okay. Take your asymptote and subtract 2. And x-intercept, I don't know why this is on top of this also. Find your x-intercept as well, algebraically.
When we do solve for the domain on the test, can we just write it, or do we have to show like where we got it? Do we have to show the x plus 2?
If you show it to me on your graph, that's fine. If you do a domain restriction algebraically, that's fine, unless I say algebraically.
Okay.
Same as, like, all intercepts have to be done algebraically. The domain, unless it says you can do it either way. Sometimes it's easier if you're going to do the sketches, you might as well do the domain right off the sketches.
Yeah, so like, I can just write, like, draw the sketch and then write domain 2, negative 2, and then I don't have to do that.
Absolutely. Okay, we took a base log base 5, very similar, and we shifted it 1 to the right, horizontal shift to the right 1, and a vertical shift up 4. The horizontal shift will change your domain and will change your asymptote. And then, of course, your x-intercept will change. Are you good with these? You can give me all of these. Can you do these without your calculator? You have to be able to do these without your calculator.
Can we do the intercepts, like the logs with our calculator?
Oh, the logs, yeah, I would have to do the logs with your calculator. I don't expect you to do that without.
Okay, yeah.
But you have to do the major part with it. Question.
For the domain, how do you do it?
The domain, any horizontal shift is going to affect your domain. So I would start like this. My regular domain is from 0 to infinity. You can't take the log of 0. You can't take the log of a negative number. As soon as you have any horizontal movement, you're moving 1 to the right, just add 1. This gets your new domain. We also could say, by like a restriction, this has to be greater than 0. Do it that way first. It's even easier. You know how you use your radical? Take what's in the radical, set it greater than or equal to 0. Take what's in your argument, set it greater than 0. And then you really have no issues with the domain. A vertical shift does not affect your domain. Your x-intercept might change, your y-intercept might change if you cross over, but that's it. Base 10 just hugs it a little tighter, but I still want your sketch to be the same. And when you x negates, do it with your hand. If x goes from a positive to a negative, because the negative is next to the x, there's your reflection. Reflection in the y-axis. Good so far? And the LNs, the natural log, they work the same way. The natural logs work the same way. They're very close to a base 3. So we've got a horizontal shift off your natural log, same sketch. We went 1 unit to the left horizontally. So your domain is shifting left, your asymptote is shifting left. And of course your x-intercept shifted. Okay. The natural logs work just like the other logs. If you want to turn this one around, make it a little easier, you have a horizontal shift to the left 3 and a reflection in your y-axis. Reflections also will change your domain around, so be careful about your domain. Don't forget on an ln, the base is e. When you flip it, anything to the 0 is 1. And this one, just a basic log. I think I just forgot to, whatever I put on there didn't save.
Sorry, the breakfast line was on.
Okay, just sign the late book.
Yeah.
So this guy, just a basic log, no transformation here. And last was this guy. You're going to use one of your rules, one of your log rules. Your power rule says bring down your exponent. Because you've got to do this by hand. Bring down your exponent. It has the same effect as when we did this with your squaring function. If we put a 2 in front of here, we saw a vertical stretch. Here was our regular parabola. We saw it stretch. It pulled it up like this. If we put a 1/2 in front of it, excuse me, we saw a vertical shrink. It actually flattens it out. It changes the distance to 0. So this, when we pull it down in front, gives me a vertical shrink by a factor of 1/2. A horizontal stretch will be fine too. But a horizontal stretch, what's the factor? 2. It would be 2. Because if you're going to use the opposite effect, you're going to stretch it further, right? A stretch has to be bigger. So just flip that over, flip your fraction over. You can call it either one. Just make sure the factors are right. So that's why it's sometimes easier just to stick with the vertical stretch. You don't have to flip anything. We good with this? Okay. 3 types of equations. One when there's no logs around, and we can give logs to both sides. One when there's logs on both sides of the equal sign, and if we get them down to log, we can take away the logs. And one when there's a log on only one side of the equal sign. There's basically only 3 types of equations. Now, this one has a name. It's no different than if I did this. Okay, so what would I do to solve the right equation? Can I drop 72 to a base of 2? 72 to the what power? Right. Nope, so I can't drop it, so I can't go into an exponential equation. So how do I get that exponent down? Yeah, what's the rule? The only way to get that exponent down is with your power rule for your logs, right? So you can put a log on both sides. What you do to one side, because you have an equal side, you have to do to the other side. Can I also do ln to both sides? God bless you. It's going to work the exact same. Exact same. Now, using my power rule, I can bring it down. And then all I have to do is divide by log 2. Or ln2 in this case. Okay, now, if I want the exact answer, this is my exact answer. If I want it rounded to 3 decimals, I put it in my calculator and I round it to 3 decimals. These work the exact same way. You'll get the exact same answer. Like I said, if you look through our book, it's a college level book. They mostly just use ln, because ln is kind of universal. It can be used for anything, the e and the regular bases. Whereas with an e, you must use ln. So you're going to see most college books, instead of saying log 2, log 72, they'll just say ln. Now, this one works the exact same way. We need to get this down. This is just base E. This is the same as if I put a 2 in here. I have base 2, base E. So I'm going to need a log to get that exponent down. My power rule says a log. So with an E, I must use an ln. Same setup. Bring your x down. And what's the property when I have ln and e? They cancel. Look how nice that is.
What is that X?
The x came down from the exponent.
Wait, so why did you put 2? You're just showing us.
I was just showing you, if I showed you with base e, I didn't want you to get confused.
Oh,
So I showed you with a base 2. I could also put a base 3 in here. I could also put a base 10 in there. I could also put a base e in there. So I wanted you to see whatever the base is, the exponent is still needs a log to bring it down. So we can use logs, we can use ln, but with the e, we must use ln. And that little property there, remember we talked about this little property of it canceling out? This is the one that's most handy. Okay, and again, if you gave me the exact value, it would look like that. If you give me to 3 decimals, then you plug it in and your 3 decimals would be. Now, a nice way to check this, it is an equation. Take E and raise it to the 4.277. You will get approximately 72. Because we rounded, you will get approximately 72. Okay? Here's another cute thing. If you left this here, watch. If you stuck this in for x, E, and I stuck this in for x, raised to the ln 72, what happens to E raised to the ln? Cancels out. That's another quick way to check. That's a cute little row. There's a lot of ways you can work your logs. This is your basic equation when you have no logs. Now, same setup, only difference here is what's different.
There's a plus 5.
There's a plus 5. So the first thing we need to do, we can't put logs to both sides unless they're one term, one term. So we're going to subtract the 5. And then we're going to do the same thing. How do we get that x down? From our power log. So what do we have to do to both sides? ln. This comes down. And what happens to the ln e? Cancels out.
What? So you want us to use ln?
With an e, you have to use ln.
Why did you show us the log for the first one?
Because with any base, you can use a log. If it's base 2, if it's base 3, if it's base 4, base 20. But with an e, you have to use an ln. The reason I showed you that, too, is because you can also use an ln for base 2. So my goal behind that is use ln for everything. Just use ln all the time.
Alright.
So I was trying to show you whichever you put in there would work. But with an e, you have to use ln. Have to. Now, this guy has a couple of different ways. It is one term, one term. If you take the ln of both sides, then you have a product rule. Okay, we can do it either way. We can do it with your product rule, or we can do it with a divide. So, if you want to take the ln of both sides, can I bring down my 2x? Look again.
You have to do the plus.
Who does the 2x belong to? E. Only E, not the 4. So, what's this going on here?
ln4
A
plus
product. Good. ln4 plus.
2x ln.
Okay, so you brought your 2x down.
Can you divide 4 and then do ln?
Yep, we're going to do that next. And then this is ln5.
And can you subtract ln4 from ln5?
Yep. So we're going to subtract this and isolate this guy. But you can't do 5 minus 4. The ln belongs with the 5. You have to leave it like that. You can't do 5 minus 1, 5, 4. Excuse me, 5 minus 4. Now, which variable am I solving for?
Yes.
X. What happens to the ln e?
Oh.
So what do I have to divide by?
2.
2. Now, when you divide, make sure this is in parentheses. So tell me what you get when you divide.
Oh, you want like the numbers?
Like a 3 decimal.
Do you alter a number, or do you want to just like simplify it?
Well, if I ask for exact value, that is your exact value. But since we usually round to 3 decimals, unless I say exact value, we just always round to 3 decimals. When you check it, then you know it's going to be approximately 5, not exactly because of the rounding. So 3 decimals, what do you get?
1.
Okay, now, somebody said, can we instead divide by 4? Absolutely.
Oh, yeah.
Shh, guys, come on. Now, same rule, ln of both sides. If you want to make this 1.25, if you want to keep it 5/4, I would not at this point do ln 5 minus ln 4 because that's what you're trying to avoid over there. I would just leave this 5/4. That's fine because there's no variable in that number. So then, again, 2x is equal to ln and then divide by 2. Okay. So either way you want to do that, make sure you isolate your variable first. Good? So we're okay with whether we have a base or an e, you can use ln. If you have an e, you must use ln. So the easy way around this is just kind of always use ln. That's why most college books just use ln. The high school books, they're showing you logs, so they tend to use logs a little bit more. Now, here's the second kind of equation. I have one log somewhere.
Isolate it.
Good. We have to isolate this log. I can't give logs to anybody else. So let's subtract 5. I can't put logs on both sides because I have a log here. I can't cross it out because I only have one side that has a log. Whenever you have this situation, you're going to go back to an exponential equation. So we're going to isolate this guy. So let's divide by 2. And remember, this is pre-calc. I don't always look so nice. As long as you follow the rules, even in Algebra 2, you had a lot of answers that weren't the nicest looking answers. Now I want to flip this to an exponential equation because I can't cancel out my log and I can't put logs on the other side. So when I flip this, what's the base of my ln? E. So e to the what power? Negative 1/2 equals x. And just put that in your calculator. That would be your exact value. But if you raise to 3 decimal places, if you go to 3 decimal places, I don't know if I have this one. Yep, I do. Now, it's an equal sign. So you can again check this. Put in your calculator. You'll get approximately 4. They're equal signs. They're equations. Just like you plug in your x and substitute, this is still x to plug in.
That point's calling out.
Am I lost?
You're right. I think I was in 107.
Okay, so this is the second kind of equation. Whether this says this or it says log. Let's make this a log base 2. Same way. I can't get rid of this log. So again, we isolate your log. The same procedure. Divide by 2. Isolate that log. This usually looks better because we can actually see a base here. 2 to the negative 1 half equals x. Okay? So it's the same procedure, whether we have log, whether we have ln. What if we had this? So I get down to here. What do I do now? This is a base 10. Put your 10 in here, just like you had to put your e in there. We don't have to write a 10. The 10 is understood. Just like the e is understood. We don't need to write the e. But if you need to flip this, you need to write that in there. Sometimes what happens, and I've seen kids, they stare at it and stare at it, they're like, I have no base, what do I do? Think back, where is that base? Okay. So that's the second type of equation. When you have one log, whether it's a log or an ln, you only have one of them. And the third type is when you have logs all over the place. So what our goal is to make one side be a log and the other side be a log, one term, and then we can cancel out the logs. If you remember back to one of those rules that we did with the property, and it said x equals y, we can do log x equals log y, and take the logs away or put them there. What was one of our properties, the same with ln's. It was on your property sheet. It was the last property. I'm pretty sure it was.
The square root property.
No, not the rules. You remember those properties that I gave you, like the ln e cancels out to 1? It was a list of properties. You had logs on one side, ln's on the other side of the page. This is like one of the last ones. You put logs on both sides, but they have to be one term. So we have to condense this to one log statement. This is a plus. Think back to exponents. What were we doing when we added our exponents? Multiply. This is your product rule. ln, make this a product. Where did this 2 come from? It was an exponent. Move it up there. Now, you have one term on the left. It's okay, it has many factors as it has, but you have one term on the left, one term on the right. You can now take your ln's away. Okay, and then you're going to solve. Now, the important thing about this is you need to check. You need to check your answers, especially when you build a quadratic. When you build a quadratic, usually you have one that works and one that doesn't work. Sometimes they both work. Don't rule it out just because it's negative. Well, this guy would not take a negative or a 0. But sometimes it's set up so that maybe the negative would work and the positive won't work. So make sure you check them both. So let's FOIL this guy out. And then what do we have to do to solve?
We'll combine like 3.
Combine, get them all to one side because you have descending variables. Yep, this is the trickier one. No square roots. Factor.
X minus 1 is,
No,
X.
x minus 3 is minus 2. Oh, sorry, no. Yeah.
Try again.
No.
X minus 6, X minus 1. You need factors of 6. When the signs are the same, factors of 6 that sum up to that middle number. So, x is equal to 6, x is equal to 1. You got to check this. All you have to do is this. Watch. Put the 6 in here. The 6 minus 2, can I take the log of 4, the ln of 4? 6 times 2, 12 minus 3, can I take the ln of 9? Can I take the ln of 6? Yes. So this should work. I mean, you can absolutely put it in there and check it, but technically that one should work. The 1. Can I do 1 minus 2? Can I take the log of negative 1? No. So automatically, I reject this. Now to really make it work, just plug that in your calculator and make sure that it works. You can't take your domain for your logs, says 0 to infinity. Question? Oh.
So you can just cancel out ln's
Only when you're one term, one term. One of our properties is you can, on one term, you can put logs to both sides or you can take logs away from both sides. But it has to be one term, one term. It can't have anything else in front of the log.
Does the one always cancel or does the other one?
Which,
Does it cancel the one?
this guy here? Not always. We have to check them. Because you can have this situation. And then the one would work. Even the negative one would work in here. So don't cancel it just because it's negative. Try them. Try them. Sometimes it's even set up like maybe there's a negative in here where only the negative works and not the positive. Okay, so these are